Thanks for coming, guys. My name's Ian. This is my lightning talk on lightning and other electrical phenomena. So first, a disclaimer. I am a lightning enthusiast. I'm not an expert, not a scientist. If I say scientists don't actually know how something works, that might just mean that I don't know what I'm talking about. Watch for that. So when does lightning? We need a couple preconditions before we can actually get lightning. First, we need a sufficiently high electric potential between two regions of space, so a positive and a negative charge. And in between those two things, we need a high resistance medium. So it has to obstruct these two charges from equalizing. And a high resistance medium could just be the atmosphere, obviously. So the air is the insulation between these two charges that want to equalize. And how does lightning? It's not well understood, but
By you.
by me. So when a thundercloud comes over the ground, it has there's a cloud, and then there's lightning. It'll have a very high negative charge, and when that charge is high enough, it will start to produce a channel of ionized air beneath the cloud, which is called a leader. And ionized air is also called plasma, which is really awesome sounding. So this channel of plasma comes down from the cloud, from a negatively charged region in the thundercloud. So it could be negative regions, positive regions. So it's basically the cloud starts building this bridge down from the cloud through the air. And these leaders are electrically conductive channels because, like I said, the air, just as it is an insulator. So it needs to build these leaders down where the electricity can actually flow through. And the reason that they're conductive is because ionized gas has the electrons are basically stripped of the molecules, so the electrons are more free to flow. And it's not well understood, so hand waving. So we get negative leaders that come down from the clouds, but you can also get positive leaders that come up from either from the ground or from a pole or something on a building, so they can actually meet. I have a pretty awesome high resolution demonstration of that. As you can see, we have the negative thundercloud and the positive ground/building/tree. And I'm gonna hit play. Are we ready? So we have a negative leader is coming down, which is this ionized channel that is looking to connect to a positive leader, which is coming up from that pole. Then we have, when the negative leader attaches to a positive leader, the bridge is basically built and the electricity can actually flow in a process known as attachment, which is it's a scientific term, but they attach. So after attachment, we get the return stroke, which is the most noticeable part of the lightning. This is the point where we actually see the big flash. So it's an enormous positive current that flows up through the ionic channel to the cloud. Return strokes average about 30 kiloamps for a typical cloud to ground flash. And the core temperature of the plasma can reach about 50,000 degrees Kelvin, which is pretty hot, I guess. I don't really know Kelvin, but it sounds hot.
It's the same as Celsius.
Okay.
Well, 50
Give or take 270.
And then you subtract something. Okay, it's hot. So the massive amount of current combined with the speed at which this current flows rapidly superheats this plasma channel, which gives the flash, but it also expands the air so rapidly that we get a shock wave, which is thunder. Could be a whole separate talk. Thunder's pretty cool. So we have a few different types of lightning. The one that we think of the most, I think, is cloud to ground, because we can actually have a physical contact point where we can study it, we can be afraid of it, run away from it, that kind of thing. But it's actually not the most common or the most frequently, the frequent type of lightning. That would be intra-cloud. So within the same cloud, you have, like I said, you have positive regions, you have negative regions, and within the cloud, there's lightning as well.
Is this the same cloud where all my files go?
Yes. Well, there's a few different types. There's Dropbox. There's SkyDrive. Yeah.
Those are fast.
Okay.
Yeah. Intra-cloud is when you move a file within Dropbox to a different folder. Yeah. So there's also cloud to cloud, which is when you, So a negative region in one cloud, positive region in a different cloud, and then you see lightning between them.
Can we restart this talk with the cloud to butt plugin?
So there's butt to ground, there's intra-butt, there's dark, doesn't have cloud. So there's dark lightning, which I don't understand at all. It has something to do with gamma rays, which I know from the Hulk. I don't know. And there's also something that is called a relativistic runaway electron avalanche that's related, which sounds like it could be an awesome band name. Maybe thoughtbot band. Keep that in mind. So there's different types. There's also different observational variations, which are less scientific. It's really just like styles, like what does this lightning look like? So one is ball lightning, which is not really studied that much. It's more like people saying, yeah, I saw a big ball of lightning and it was crazy looking. We don't know much about it, but it may or may not be a thing. It's a very good magic card, if anyone plays magic. No? Thank you. Tom, all right. Forked lightning is lightning that has a lot of branches. It's forked. Heat lightning is interesting. So has anyone heard of heat lightning or used the word heat lightning? So it's kind of a folk science term because it's not actually associated with heat. But I think what it actually is it's lighting that's off in the distance so much that you don't actually hear the thunder. And for some reason, someone associated that with being warm out, and now it's heat lightning. I don't know. Pretty cool. Super bolts are awesome. So super bolts are 100 times brighter than a normal lightning bolt, and they happen about 1 in a million. 1 in a million lightning bolts are super bolts, and they're just really big, strong lightning bolts. But they have a great name. Extraterrestrial lightning is not necessarily controlled by aliens, but that's the first thing I thought of. So it just means that it's lighting that's off of the Earth, out of the Earth's atmosphere. Kind of more boring than I thought. But it has been observed on Venus, Jupiter, and Saturn. And if you like super bolts, which you should, Jupiter has a lot of super bolts. So check it out. Go there. I don't know. There's rocket-triggered lightning. Check this out. So we have designed a way to trigger our own lightning bolts using rockets. Yeah. So what we do is we we shoot these rockets up that trail a spool of wire. So we shoot a rocket up, it has the wire trailing it, kind of like a kite, and then we shoot it up into a thundercloud, and that's ready to basically produce lightning. And then it sees that spool of wire as the lowest resistance way to get to the ground, and takes the path and destroys the rocket, and we have lightning. It's pretty cool.
Do we use it?
That's pretty brave.
Yeah, so rocket triggered lightning and also laser triggered lightning are two ways to trigger lightning. One is to study lightning, but the other reason is to actually protect power plants, protect these big buildings that we don't want to actually get hit by lightning, so we trigger it somewhere else, kind of dissipates the charges, and then hope for the best. So laser triggered lightning, we use infrared or ultraviolet rays, and it's a similar idea. So it's basically, it's kind of like cheating, like we're creating this channel ourselves instead of letting the ionized channel happen naturally. So it's providing this ionized channel of gas through which the lightning can reach the ground. Yes, protects stuff. Also, it's just cool. I mean,
That's a rocket launching.
The ones that are launching the rockets.
right, yeah, you got to protect the lightning rockets with the laser lightning. It's a meta talk, just go with it. So there's also something this is pretty awesome that DJCP told me about is petrified lightning. Yeah.
That's like poop.
So, looks like what?
Poop.
Petrified butt.
I was gonna say it looked kind of like a gold-plated ginger,
That works too.
which was actually my nickname in college. That's a whole separate thing. So petrified lightning, also known as fulgurites, are these natural hollow glass tubes that are formed when lightning hits sand that is high in quartz content. So lightning that is sufficiently hot enough, which is about 3,200 degrees Fahrenheit, if it strikes the right mixture of sand, it can create these hollow tubes that are glass, basically instant tubes of glass.
I saw one of these in a museum that was about 5 feet long.
Wow.
I guess they're really hard to excavate.
That's so cool. So they study these in across the world to see, I guess, make weather reports for the past. I don't know why that's useful, but they can say like in the Saharan desert, for example, these are all throughout the desert, and they say, oh well, there must have been a lot of lightning storms here. So very helpful weatherman. Thanks, guys. So let's talk about other electrical phenomena like corona discharge. Corona discharge is brought on by ionization of fluid like air surrounding a conductor that is electrically energized. I just read that exactly. So corona discharge, if you observe it, it looks kind of like a bluish glow, which is pretty cool. And it's usually adjacent to pointed metal conductors because the charge, something about the charge, when something is charged, the charge actually focuses on the like the edges of the thing, something. Faraday cage? I don't know. Just, science. My dad's a science teacher. I hope he doesn't watch this. Anyway, so this phenomena has some pretty cool commercial applications. So they use this to sanitize pool water. Apparently it's used for photocopying.
What?
I don't know. But this one I will try to explain. Solid state fans are pretty cool. If you've ever heard of solid state fans. So it's a It's a fan with no moving parts that they've used for computer chips, for example. So it's basically, it has a positive electrode, a negative electrode. The negative electrode, creates negative ions around it, similar to how the channels form for the lightning. You get the ionized air. And then the ionized air repels from against the negative electrode because the same charges repel. Science. Which pushes the air across whatever you want to cool. It's pretty neat. Yeah. So, St. Elmo's Fire is more than just an 80s movie, I learned. It is a type of coronal discharge that sailors would observe on ships. So they would see these ships coming at them through a lightning storm, and the tall masts would act as the electrodes coming through the negative charged clouds, and they would actually see these great blue glowing masts coming off of the top of the ships. And some thought it was a good omen, some thought it was a bad omen, but it looks cool either way. And St. Elmo is the patron saint of sailors, so they thought it was like St. Elmo coming down and helping or hurting them. Again, I have a pretty helpful picture of this. This is St. Elmo. As you can see, the plasma is coming out of his hand. No. So if you could kind of ignore St. Elmo there for a second, this is actually somewhat accurate of what the blue plasma would look like coming off of the ship. And there's also an iPad case with St. Elmo's Fire. I don't know who, not sure what kind of market they're going for here, but it's pretty cool.
Very literal.
Yes. Yeah, so that's about it. Everything is amazing. Lightning is amazing. Science is amazing. Wikipedia is amazing. So yeah, stay curious and be amazed. These are my sources.